Hello everyone. In this video, we will be discussing exclusively about helical gears. So, what is helical gears? It's a transverse and normal module of helical gear, formative number of teeth, and the design of a helical gear based on strength, dynamic load, and wear. So, all those things we'll be discussing in detail. So, already for the spur gear, in the previous videos, we have discussed. So here also the same procedure I'll be following for solving the helical gear problems also, and even I can say like 70 to 80% the design procedure remains same. So here and there we will be just changing the formulas that we should be knowing on what basis I will be changing the formula. So I think just if you want to understand the helical gears in better way means we need to compare it with the previous one, that is the spur gear, because the procedure what I will be following to understand the helical gear, it is based on the spur gears only. So we know like spur gear is something where the two gears like pinion and gear, or gear and pinion, whatever thing, where the shaft axis should be parallel, or even we can call it as a coplanar, and the teeth it should be straight, and it should intersect with each other. So that is the thing of the spur gear. But what about helical gear? You can able to see this helical gear where it is also we can able to see like the shafts which is almost parallel to each other, but in each way this helical gear is different from the spur gear. So helical gears are similar to the spur gears except that their teeth are cut at an angle to the whole axis rather than straight and parallel to the whole like the teeth of the spur gear. You can able to see this here. The teeth of the spur gears are cut an angle to the whole axis. So the teeth you can able to see when the gears are mating with each other, where the angle it is producing it is rather than straight, and which is parallel to the hole. So like the spur gear. So the line of contact between the two teeth is not parallel to the teeth but inclined. So this ensures a gradual engagement of teeth from one end to from one end of the tooth to the other, rather than a sudden engagement as in case of the spur gear. So this gradual engagement makes the gears function smoothly without much noise. So this is the major difference between the spur gear and helical gears. So we should even aware of some of the important concepts related to this one, that is the transverse and the normal module. So the difference between the transverse module and the normal module is defined as the difference of the basic tooth form. So basic tooth form difference is nothing but that we will be calling it as a transverse form. So as shown on the sketch rightly, the module of the tooth datum orthogonal to the center axis of the gear is nothing but the transverse module. You can able to see which is the module of the tooth datum, which is orthogonal to the center axis of the gear, which is called as the transverse module, and the module of the tooth datum orthogonal to the thread helix is called as the normal module. So this is the transverse module and this is the normal module. And if you can't able to understand the definition, at least if you look at the sketch, you can able to understand. This is the teeth for your understanding purpose I have shown here. So this is the transverse module and the normal module. Then we have the same concept, that is the formative number of teeth in a helical gear. So here the formative or the equal number of the teeth for a helical gear may be defined as the number of teeth that can be generated on the surface of a cylinder having a radius equal to the radius of curvature at a point, and the tip of the minor axis of an ellipse obtained by taking a section of the gear in the normal plane. So I think I should go back to the sketch. So here the formative number of teeth, if you want to understand me, just we'll go with line by line. The formative or equal number of teeth for the helical may be defined as the number of teeth that can be generated on the surface of the cylinder. So you can able to see on the surface of cylinder how many number of the teeth are generated having a radius equal to the radius of the curvature. So the radius should be equal to the radius of the curvature. For example, how many teeth we can able to see? For example, 1, 2, 3 teeth. So in this way, equal to the radius at a point of the tip of the minor axis of an ellipse. We know what is the major axis, minor axis. That is, the minor axis usually will be measured from the smaller v. So obtained by taking a section of gear with the normal plate. So that is nothing but formative number of teeth. Usually, like in this particular sketch, where I can say like the formative number of gears will be 1, 2, 3. So similarly for different problems and different sizes, the formative number of the teeth usually it varies. And generally, when we speak about the strength and like other perspective of like strength, wear, and the reliability of the gears, so the perceptions would be like a bending strength and the durability. So these bending strength and durability specifications are applied to the spur gears and helical gears, including double helical and internal gears, and it is to be used in the industrial machines with the following range. So the module, and this is the data we supposed to remember. So the module M is 1.5 to 25 mm, and the pitch diameter it is 25 to 3200 mm, and the tangential speed it is 25 meter per second, or it can be little slower also, and the rotational speed it is 3600 rpm or slower. See this, we should go with these standard values, or let's whatever the range they have specified. Then we can able to avoid the like the failure of the machines which they are exclusively using in the industries. So in order to find the strength of the helical gears, a modified Levy's equation is used. So that since I cannot use the same Levy's equation what I used for the spur gear, here I'll be going with the modified equation that I'm be denoting as y dash. So which is equal to tooth form factor or the Levy's factor corresponding to the formative or the virtual or the equivalent number of teeth, where V, B and C have usual meanings as what we discussed in the spur gears. And the next one, designed for mechanical strength, that is based on the Levy's equation. So here the major parameter remaining in a gear design is width of the gear teeth, that is small b, and this can be determined by checking whether the maximum bending stress induced by tangential component of transmitter load Ft at the root of the gear, whether it is greater than the allowable stress. And here a pair of helical gear used to connect a parallel shaft must have the same pitch. This is the conditions what I am telling to avoid the failure, and the pressure angle and the helix angle, but there will be opposite hand gears. That is, one will be left hand gear and other will be the right hand gear, and there is a point of contact between the two gears, whereas there is a line contact in the helical gear. With this, all this basic design information gets completed, except this few changes like the modified Lewis equation and the ranges what they follow in the industrial machines, and the formative number of teeth concept, and the transverse and the normal module. We will be following the same design procedure for solving the helical gear problems also. Correctly speaking, not solving, we will be designing the helical gears. So before moving to the numerical, we clearly once again discuss the design procedure for the helical gears. Then afterwards we'll move to the numericals. So with this, video gets completed. Thank you.